All right, everyone. Hello, welcome to our webinar. This is the second one that SenseGlove is doing, so we just wanted to give a big thanks to everyone that's attending. My name is Chloe Schrijnemakers, and today we have Gijs with us, who's the co-founder and CPO of SenseGlove. And we also have a special guest, Eric, who is the Associate Director of Haptics at Razer. Today, they'll be discussing the best implementation practices when applying haptic interactions for immersive technologies. And we're streaming on Riverside and also in LinkedIn. So hello to everyone joining from there. And also for both groups, if you've got any questions, just send them through to the chat. And then at the end, we'll make sure to go through as many as we can. So without further ado, I'll give the floor to Eric now.
Hey, thanks a lot. Thanks for the invite, Chloe and Gijs. So, hey guys, I'm Eric. I'm the Associate Director of Haptics from Razer, and I work in haptics since sometimes. I like it very, very, very much. So probably if you are in haptics, you know me. If you don't, I say I'm a passionate haptician. Let's put it in this way. And today we are going to talk about a little bit onto how can we design compelling immersive experiences by using haptics, which are tailored to the use case. So we'll try to be a bit formal in the first place, but thanks to Gijs, we'll be able to tie it to reality pretty fast. But for who doesn't know really, let's start with haptics. So what's haptics? So haptics can be defined in many, many ways. Well, how I like to define it is that they are interfaces with tactile agency. What does that mean? They are interfaces between the digital and the real world that can touch you back, so that they are able to transmit to you a tactile experience, whatever that may be. A controller is a haptic device, a Haptics glove and a SenseGlove are haptics device, Ultralip is a haptic device, or the vests. So by looking at the device is what usually people think about haptics, right? But there is a lot of things behind the device. And what we are going to talk about today is how can we effectively choose the right technology or product for the use case that we want to solve. What is the process of thought to arrive there? Maybe the answer is that we don't need haptics, which is also a fair answer. So without further ado, let's go in. Let's spend a few words on the perception of touch. So what I have here on the screen is let's say a computational model that is proposed in literature by a company which is called SynTouch, and in no way or form wants to represent reality. This but is helping us to understand what's going on the touch perception sense and on the haptic device. So the technologies that mediate the perception of touch. So we can, this company proposed a model of 15 different dimensions to represent a touch sensation. It's a computational, it means that comes from a sensor and to classify materials. And these big models, well, let's say it includes a subset. One is compliance, friction, texture, adhesive, and thermal properties, right? And they computed like 15 dimensions. However, when we superimpose what haptic technology, which means technologies that are capable to render haptics or touch signal, what happens is that we can cover a really, really small area for each tactile sensation of this area. What does actually in practice that means? That means that we might be really good, for example, to reproduce vibrations with a vibrotactile device. However, we are absolutely incapable with that device to reproduce compliance, and vice versa. So that means that haptic technologies are quite good for really specific use cases. And it's really tough to transport to another type of use cases a specific device if we didn't thought a little bit at the beginning on how we could use it. Okay.
But Eric, if we combine, let's say, the actuators here in that you listed on this slide, are we then able to kind of feel digitally how the real world feels, or how far are we from that?
Unfortunately, no. The reason it's relatively simple is that even these type of haptic technologies that exist today, their capabilities to render the real properties are quite crude, first. Secondly, is that our human perception of touch, it's really an integration of these 15 different dimensions, which means that even if we cover 2 or 3 of these different, let's say, area, for example, we do vibration, we do compliance, and we do thermal, it's still a really, really crude representation of reality that can be helpful for something, but for sure is not simulating. So we cannot fool yet the user to touch really something that doesn't exist. Thanks for the question, Gijs. So given this basis, let's forget about simulating reality. Let's think about, okay, I have a technology, I have something, and I want it to be useful for me. And that actually arrives to one of the first actually key, I think, key learning of today, which is realism-inspired haptics is really usually underwhelming. And definitely that should not be something that you should plan within your content without acknowledging that it would be always something not perfect, let's say. Let's, however, look a little bit about the sense of touch, right? There is a reason by which touch is like that and is quite challenging, is that if you look about the sensing area for vision, audio, and smell, they are relatively concentrated in a small part of the human body, and even the receptors are really quite concentrated. So when you want to reproduce, let's say, vision and audio, you need to focus on just one specific area. However, tactile perception is definitely not localized. It's all along your body. And most of bodies are different. And there is enormous challenges of ergonomics. There is enormous challenging of forces because our body exerts a force on reality. So there is definitely an increased number of challenges compared to vision and audio to be able to develop and implement compelling haptics devices and experiences. As I said, device ergonomics is really challenging. And also the dimension of the haptic actuators, it's compared to the human body, if you think about, let's say, a retina displays or a full immersive displays, is gigantic, which brings it to really a high complexity, specifically to arrive at this dream of the holodeck of the complete immersion. We are sadly quite far away from there today.
And Eric, just to specify, with retina display, you mean a tactile display as realistic as we have now TV screens?
Let's say a retina haptic display would be like a haptic display where you cannot distinguish the position of 2 separate actuators that are indenting your skin, and you perceive it as a continuous shape changing or continuous stimulation. That would be for me. And let's say there should be like 48,000, around 48,000 points along all the human body if you compute how near needs to be the haptic actuator around all the human skin.
That sounds really up the complexity, like 48,000 actuators to have a full display.
Full retina, yeah. And also we are really far away from the capability of the actuator to stimulate the right range of sensations. So you need an actuator that pushes the skin really, really slowly up to 1 centimeter, but is also able to vibrate up to 1 kilohertz. And that's really, really tough. Let's say we are really far away from these types of devices today.
Well, thanks for the reality check.
Yeah, it's challenging, let's say. Okay, so let's go back to VR, right? So we have a really nice devices here. This is a Quest 3. That is really cool. It's realistic visual and audio. It's compelling. This is a growing industry. It's going really well. But then what's going on with haptics, right? So what's going on with haptics? And there is a myth, let's say, or at least a leitmotif that comes, I think, from from some past bad experience of the market with haptics, that haptics is also perceived as hard or not bringing value, right? However, that often happens if haptics is taken for granted pretty much like visual and audio, and implemented with the same design principle as let's try to simulate, right? And with Gijs, which is also author of this nice book that we published with the Haptic Industry Forum, and which will be the content of which will be the second part of the webinar. We try to think about how can we then give a structured way to implement haptics in extended reality, which would not be hard, and we would focus on value first.
And
so,
let's say I'm thinking about implementing haptics. What are kind of the preconditions that I need to consider in order to even dive into the big pitfall of haptics?
So the preconditions, we'll see them in the next slide, but there are many actually. Most of all, you need to focus on to what is the objective that you want to achieve with your content in general, and within that framework is there a place for haptics to reinforce the objective that you want to achieve within your content? So it's really related to why are you doing what you're doing, and is there a proven or a compelling way for haptics to support what you're doing, basically.
Now, don't start with the question, can haptics add things to me? But imagine already this is what potentially a goal could be of the haptic technology inside my experience.
Exactly, yeah. You should really need to focus on value first. And this ties really with the first, the first, let's say, framework, which is, we always need to start from the goal, okay? This is a goal not of just of haptics, but really the goal of your overarching content first, and then translate that of the goal on haptics over your global content, right? Then this is the design part. Then from there, we can sketch out the interaction, and we'll see that every step along the way here. Sketch out the interactions and imagine which types of effect you would like to have for each interaction. That will help you to decide which type of framework and software framework to use. And just at the end, which hardware is compatible with the framework and is coherent with the effect and interaction that you choose and the goal. And just at that point, you start implementation. Then you start implementation from the hardware up, because there's maybe new hardware, it's new SDK, whatever. But in general, there needs to be a deep reflection before starting, and you probably should have pretty much sketched out what you want to give. Okay, you can then ask for help to some external, let's say, experts. That of course is possible, but the book that we shared, I think, will give you really the basis to approach this problem alone. By the way, it's an industry association, so it's not for profit, so we are not profiting at all from that book. So it's absolutely for a community. Of course, in everything, specifically in interaction, you really always need to consider multisensory. This, I think, is a fundamental piece of information that you should always keep in mind. Specifically in virtual, so this is how different multisensory experience can be. Multisensory means audiovisual and haptics, right? And the perceptor that you see on the screen is what does the creator want it to, which information he wants it to deliver. So, due to the fact that touch is non-perfect, it cannot be really simulate reality, it should always be there to reinforce what visual and audio bring to the table. It should never be used as a separate channel of communication. I give you an example. You are manipulating, let's say, a virtual glass like this one, and then you send a Morse code through touch, through haptics to the user, which is another type of communication channel. that should never happen, because due to the fact that it's imperfect, you would just distract the user from what is focused on. This is something in reality might happen quite a lot of time, that you have two different percepts at the same time, visual, audio, and one haptics. Let's say you're talking with someone, but you're still holding your glass, for example. That's two separate things that in reality you can do pretty well. Or you're switching on your lights at your house while talking or walking with someone. These are two separate percepts, but in reality you can do them really well. In virtual reality, due to the fact it's imperfect, it's really tough. Secondly, haptics should be used always as a secondary sense, which means that reinforces and supports the other. It's not the main driver of the interactions. And finally, it should be always be in time. So it should be always time coherent with the other two. By respecting these rules, you can start to see how haptics is there to increase the value of the content. It's not there to implement something new. But by increasing the value, it means that your objectives can become more achievable or more effective. There is a couple of things to consider, which are the latency requirements, which in general should be as low as possible. As we said, this is usually today managed by hardware manufacturer and SDK manufacturer. But if you want to build your own stuff, latency is a big challenge. Just to keep that in mind, it's one of the hardest things to nail, but it's the first things that you notice if it's not done properly. And this is something that device manufacturer solve usually when you acquire something from them. Another things to realize and to think about is, what is the haptic interaction framework that you are looking at? What does that mean? Are you looking to have like a haptic vest that showcase some ambient interaction or events on the human body to increase the immersion or the user experience? However, it doesn't have any interactive property. In that case, haptics is pretty much like a listener, like it's a display upon which haptic tracks or haptic event get displayed, but it doesn't really contribute to the interaction and the interaction of the content.
So Eric, in what type of case would this like suit your, like what are applications where passive
gaming, of course. If someone shoots at you, or simulation, yes, it's all the types of simulation that involves like military simulation, for example, getting shot, getting someone that taps on your shoulder, all these types of things, like interactions between the environment and other avatar to you, gets really well reproduced with a VR vest, for example.
So you're feeling something, but your hands are tied to your back, basically.
Yeah, exactly. You feel it on your body, and it's useful to definitely increase immersion. That's what it is. And in some cases, increasing immersion has a real value, potentially for simulation and for training. The other option is the allocentric, which means that you are interacting with the environment. In that case, haptics is definitely more challenging, because you have an interaction of the human avatar with the virtual systems that sends you back an information. This is, for example, like a SenseGlove. You are always using allocentric haptics. That means that you needed to have an interaction framework, which means how we interact with the virtual systems, that takes into consideration haptics, which this is really definitely non-trivial, because if you think about it just by hand tracking, there's really a bunch of things that with a haptics device, like for example, force feedback systems, you would not do, like remote control of remote interactions, or these types of things. If you have haptics, you can allow yourself to be more near to the interaction that you have in reality. And in that case, an allocentric haptic interaction framework is most useful. But the point is that you need to choose this when building the content. And there are many around. And you can decide to use one provided again by the device manufacturer, or you would decide to build your own based on something that already exists. both, or you can build your own, let's say, simulation system based on this. So all of these are valid answers. You just need to be extremely careful to be sure that your haptics interaction framework responds to the need that you posed yourself from the goal. Okay, if you don't want to optimize for, let's say, for realism or simulation, then there is no sense, for example, to use a full-fledged physics engine to drive haptics without any abstraction, for example. So all these things really need to have a careful consideration. Otherwise, again, you would not be able to achieve your objectives, and haptics is hard or doesn't bring value. The reality is that you didn't pose enough time to think about what you were doing, basically. So let's recap a little bit here before moving on to the next section. Is that haptics for extended reality really should, what we call, be a secondary perception. Secondary perception means that it's there to help. It's not the primary things of what's going on in VR, but it's there to help you achieve something. Okay. We wanted to reinforce a percept, and a percept is what is the global understanding and perception that is going on into the context, into the content, and then ideally have zero latency, which is impossible. But yeah, that's what we should strive for, at least from an implementation standpoint. Yeah, how can we do that, right? That's a good question. And in the next session, what we're going to try to do is to give you a guidebook, a handbook on how to think about this thing. And again, in the book is quite explain it a bit more. The book is for product managers. And the idea is that how can I approach this thinking in a rational and structured way? Let's go back to our nice, our nice graph, right? We talk about the goals, so the design from top to bottom, and then the implementation from bottom to top, right? So let's take it from the top, the goals. So why would we want haptics in XR content? We want it to increase the realism or to increase the immersion, which are two separate things, actually. Sometimes when you increase too much the realism, you lose immersion. Maybe you want it to increase the user experience, or in case of training, you want to maybe use it to increase the skill transfers, so make your training more effective. Some of these are proven in research. Some of that are not. They're strong indications. But at the end of the day, the real question is it helping your goals in any way or form? In case it is yes, you definitely should consider it. Then we discussed about sketching haptics interaction, right? So we did a lot of, let's say, a lot of work to try to classify, identify classes of interaction which could be used to map out into a scenario what you want your haptics interaction to be. For example, there are the dynamic interaction. This is, for example, a lever, which is you need to interact with a dynamic object, to handle it and move it and release it, for example. Or there is the manipulation interactions. For example, these objects are small, or they are manipulation of large objects. Why they are different? Because the motor control, comes from science, the motor control that you use to manipulate small object, you use your finger, but if you manipulate larger object like a glass, you use your wrist. So that makes sense that they are split in different categories. Again, there's quite a lot of peer-reviewed research behind some of these things. We tried to simplify that and categorize it in a way that could be digestible.
So Eric, take me on an example. I want to sketch an interaction, an haptic interaction, where I have a screw, a power tool, and I need to screw that into a wooden plank. What type of haptic interactions do I need to sketch?
So you would have manipulate a large object, which is the drill, right? Then you would have, and then you can place it where you want, but that's still the same manipulation. You have to place it a certain way. Then you have a dynamic interaction, which is pressing your trigger to make it work. And then you have another dynamic, which is release it when you're finished. And the third one is another manipulation when you release it and you put it at the zero spot. So basically you have these 4 interactions, and they are one dynamic, one manipulate large object, one dynamic pressing, one dynamic releasing, another manipulate large object at the end.
And that is only with one hand, because I also have one.
Exactly.
The small object, which is the screw, I guess.
Exactly. I mean, depending if the screw was already in place or not, then you can manipulate the small screw and you place it there. Sorry, I didn't get it. You also need to manipulate the small screw. Yes, exactly.
Yes.
So thank you. By actually structuring in that way, it becomes really clear, if you know a little bit the market, that definitely you can represent the manipulation of a large object with something like a SenseGlove easily. However, if the object is really small, that becomes really challenging. So in your haptic interaction framework, you need to facilitate that in some way or form, because grasping small object like in the size of the screw, it's complex. So maybe you need to make a bigger screw. You need to use other types of techniques to make it more accessible. If for example, if you're using force feedback devices, which is not the case, for example, if you're using controllers, because in that case, controller it's a digital system, so you just pick it up and it's much easier. So this is definitely dependent onto the hardware and that you will choose later, but it's really dependent how the implementation of this haptic interaction from the context that you want to use your haptics for their goals. Okay, let's move on. So at that stage, the next step would be like to sketch out the effect and look at the framework. Again, in the book, there is some work around here. For example, if you want to manipulate, we would like, if it's important that the user is able to manipulate and feel the presence of the object, you probably want a force feedback. If that is not important, for example, if you're just clicking buttons, then a vibrotactile feedback, a glove with a vibrotactile feedback on the fingertip, that's good enough. So at that stage, by sketching the effect, you can understand which types of classes of haptic feedback are associated to the interactions. That will help you to decide or identify the framework. Okay, the framework is, are you using Unity, Unreal? Which type of haptic SDK are you using? Are you using the device vendor? You want to use a device vendor SDK? You want to use a generic SDK? There's many different options here. And again, you need probably some research on the topic. And there is, again, in the book, there is some examples of who, what, does what. It's from 2021, still relevant today. We might want to actually refresh it at a certain moment. But at the end of the day, you arrive, after this analysis, you arrive at the hardware level. It is, okay, great. I sketched out everything. I have an idea of my interactions and the effects that I want to implement. What device should I buy? But at that stage, it's actually trivial. Why? Because you have your goals. You draft out all of your interactions. You draft out the effect that you want to have. And then at that stage, you said, okay, what are the most present or the most important interaction to deliver my goal? If it is just buttons, then some vibrotactile devices over the fingertip works fantastically. If it's, however, heavily on manipulating and moving levers, maybe you want a force feedback device. Or if nothing of this happens and you only have, for example, a simulating event where you have contact on your body or something like that, that is really great to have a haptic vest. But by doing this analysis, you avoid the problems. Oh, let's prototype. Let's invest time for doing that. Why that is not suitable? Because it takes really a lot of time to get a device, haptics device up and running, and to get a hand of that, because all of them are different. So you have to relearn a lot of things. Okay, great. So we arrived at deciding the devices. There is a map of the tech here that we have in the book that allows you to, it's a bit academic, but allows you to map out what types of technologies there's around. There are examples for each technology of vendors and or existing implementations. that allows you to navigate a little bit. Again, in the book, there are, I think, at least 10 use cases at the end that showcase the usage of haptics into business scenario, or for training, or for simulation, or for other types of applications where the investments and the choices are rationalized over specific use cases. Then it's the moment to make wise decision, right? And it's sometimes not trivial. I'll give you an example. So let's say you want to have a simulative environment where you want to train for a military operation, right? There are fundamentally, if you want to, let's say, simulate a weapon, there are two completely separate ways to simulate a weapon. One is completely virtual. So we simulate the sensation that the weapons give you in your hand thanks to force feedback devices. And maybe with the vest, the sensation that shooting that weapon would give you on your body. But that weapon doesn't exist. The other end, it's a plastic prop with a controller, VR controller inside that you feel in your hand. In the middle, you might have the prop, but you implemented the haptic actuators inside, and that prop becomes active. So it actually shoots you back, okay? There is effectively a spectrum here between all of these. And the right answer is really dependent on the goals. I'll give you an example. Let's imagine that your shooting is really not the biggest part of your scenario, and everything else is as important. You need to pick up things, you need to move levers. At a certain moment, you need to pick up this thing, shoot, leave it down, and do something else. Then maybe completely simulated makes a lot of sense. However, if your simulation is all about military operations, and it's important that the weapons behaves like a real weapon, then at that stage, having a prop with enabled haptics becomes really important, because that's the center of your goals for your objective. And if you really don't want to spend any money, a passive prop is cheap and it's all right. No, it's really not bad, because the sensation of having something on your hands in VR and having the virtual representation of that in VR, that's extremely compelling. Because as we said before, that haptic device cannot simulate perfectly reality. A passive prop will always feel better in your hand than a simulated object, right? But it becomes with the constraints and the cost about it.
So, Eric,
so this is the moment. Yeah.
So we talked a little bit about cost and cost versus goals. But let's say I have endless budgets. Do I always end up then with the most expensive device? Or is there something else that I need to take into account when choosing my device?
You definitely shouldn't always get with the most expensive device, because again, haptics is related to the objective you pose yourself, and the value, actually the added value that haptics would give to your specific goal. If in example, in a specific simulation, haptics is really the tactile interaction is like 50% of your scenario, and you really, really want to have the best of the best because it's one-off installation, it's really interesting. You have maybe running research on that, and you want to make no compromises, then probably buying the most expensive one is probably a wise decision, because you don't want to have regrets later on that you didn't make it the best that you can. However, if haptics is there to bring value in a certain way or form, or maybe you want to repeat it for many, many implantations around the world, probably buying the most expensive haptic device is not too wise, because usually it comes with maybe unproven technology or difficult ergonomics or difficult repairability or shipment capabilities. Then having a trade-off between the business goals and the scenario capabilities is usually the best solution. Like, okay, you can buy a Vario for all your training systems. That's all right. But maybe you can come out alive with a Quest 3 and it costs you like 1/10. And the question is,
And
how much ROI are you losing that, right?
and it is maybe indeed an untethered device that I can use anywhere, because
Exactly.
that is also, I think, an thing where we talk in the book about it. It's called haptic transparency.
Yes, exactly. Yeah, haptic transparency, for who doesn't know what it is how much having a haptic device on you is can be felt by the user, and it's actually blocking your natural interaction movement. Of course, anything that has a cable that is blocking you to behave naturally, and having it doesn't, it's probably better. Lightweight devices are much better than heavier devices. So you really need to, at this stage, run really user study and get a grip really over yourself, and by testing it to realize what is the best fit for your content. Similarly, let's talk about again these guns here. A real gun is quite heavy and it's tiring to use. So are you using that for real military? And at that stage, you need to be as close as possible. Or you're doing that for other reasons. In that case, you can compromise over that quality, right? So it's really depending on how does it fit in a global user experience of your applications, and where do you want it, how do you want it to bring value to your goal. That's why I say make wise decision. But the important stuff is make wise and informed decision. And the informed comes from the analysis that's been done before. Right now, let's spend a few words over the framework that we discussed before. So the framework is basically it's a structured way to see how a haptic effect gets created, gets implemented in the game engine, and transcoded, transferred to the device through different protocol of communication. So I want to spend a little some words here, because haptics is definitely quite fragmented today, and can become a problem for if you want to invest in one device and want then to change and use another one. Usually you need to rebuild everything from scratch. Maybe sometimes in the future this will change. So you really need to take care to choose the right framework that will give you maximum flexibility and maintainability of your application. There are some standards that are getting created in haptics. One is the let's say the haptic asset, which are the representation of the haptic pattern, and the other ones are related to OpenXR, which connects the 3D applications to the media presentation engine, and then the USB device API to the protocol of transportation of your haptics experience to the device itself. The most important things I want to strongly underline is you really would like to build or use a developed testing environment that minimizes the testing time. Why I say so? Because tactile memory is really short. So after a few seconds, you forget what you felt. And that can be a huge issue, because it's really, really tough if you don't have an extremely rapid loop between testing and modification to remember what was wrong. So there is value to invest in flexible development toolchain in ecosystems. And as I said, there are these standards in development that will help you to divide the design part from the implementation part, from the device deployment part, that will help you to achieve this fast loop of iteration quite quickly. So I want them to spend a few minutes really regarding what Interhaptics is. Interhaptics is a company that I founded like 7 years ago and has been acquired by Razer last year. And in the meantime, I became their haptic director, associate director. But the company, what we do actually, we develop design systems and for haptics and general purpose SDK for haptics. And basically our mission is to reduce the complexity of implementing several types of haptics technologies today into content. Of course, by getting acquired by Razer, we are focused 100% on gaming, but we have a long history of virtual reality and OpenXR. And within this framework, we are working also with Gijs here in an haptic industry forum to create a better OpenXR APIs for advanced haptics that ideally would support SenseGlove and other types of interesting devices. So that would be easier for content creators to create for that. And on the other side, we work with MPEG to standardize the haptic asset coding, which means how we save a haptic experience into a digital file like MP3, for example.
So just to emphasize, today there's no like MP3 or MP4 format that I can load to a haptic device and it will play.
Not yet. Yeah, it will be that the format will be published in a couple of months actually, which is called MHIS, and it is an effort that is ongoing since 3 years. And that would be like a general purpose haptic coding format, like MP4. It will be streamed. It can be used in VR or this type of things, but that only describe the haptic experience. It's not yet distributed to the devices. So that it's a way for you to create, let's say, a catalog of haptic effects that you can reuse or describe a haptic experience over, let's say, 1 hour or a movie or something like this. We are not yet at the level where all this seamlessly flows to a device, at least from a standard perspective.
Well, at least baby steps in a really early industry.
Yeah, I mean, you need to start somewhere, and usually it's really good to start from a coding because you can separate the creation toolchain, the deployment toolchain, and actually separate the digital creation from the device itself. And then right now we are working OpenXR. We're starting to look at the USB, and that is in a way to abstract the different layers and allow this digital experience to just flow. Goes back to the design system, Interactive, we developed basically a studio for haptics, we call Haptic Composer, that allows you to edit rapidly haptic effect, in this case, vibrotactile, by looking also at the audio, so that the audio haptics experience is always in time, as we said. That's multisensory, it's important. That is available for free at www.interaptics.com, and we are compatible with OpenXR. So this is one tool that we built, and what does this tool does? So we work a lot for the haptic coding, MPEG haptics, which is very similar to our interaptics codec, and that helps to, let's say, package together the different way to think about haptics today. And by the fact that we have a kind of unique codec, we can have a unique SDK for all devices, which is quite cool. Today, we're mostly on gaming, so we are a PlayStation partner, so PS5, the Sense devices also, the Sense controller in PSVR 2 for HD haptics, the force feedback also, OpenXR, all the phones, Xbox, and before SenseGlove, right now, not anymore. We'll get it back at a certain moment. And also the controllers that we launched with Vario, with Razer, not long ago, actually 2 days ago. So yeah, basically what we do is that we provide a unique SDK for all haptics, including VR, mostly gaming today. But okay, if you do VR gaming, that's pretty cool. That works well. And in general, was like the points that I wanted to touch. You see, 33 minutes, incredible. It's like perfectly in time. And happy to get any question you want to have for me or to Gijs, because we collaborate quite a lot together.
Thanks, Eric. Before we dive into questions,
yeah.
You just touched upon a really essential point about testing your haptics. And I want to give you a good example of, for instance, how we do that at SenseGlove. That is, if we have test moments, we always have a programmer that has live, for instance, the Unity engine open, and we have a UX or product owner that is in the VR environment. And the programmer can adjust the levels of feedback or the haptic interactions live at the moment the UX person is testing the interaction. So that is like direct feedback, and you can really quickly iterate on getting good haptics. You need two persons for it, but definitely it's worth it to do it that way.
Yeah, absolutely. It's really similar to VR when you actually, the developer has the headphone, the the VR headset on the head, codes, pull it down, test, codes, pull it up. It's really similar. What we strive to do in our case is that we want just one person to be able to do everything. But I do understand that for something like a SenseGlove is challenging because you have something in your hands. But yeah.
Awesome.
Yeah.
Thanks for this.
Awesome.
And I'll leave it to Chloe to well, get all the questions from all the platforms where we're live on. And exciting to hear what the audience has to say.
Yes, so we have a first question from Nikki, and they ask if there is already research about the haptic vest in health. So, for example, physical rehabilitation, or if it's mostly created for gaming.
It's a tough answer because if I say no, you can tell me it's there. If I say yes, probably not. I know that there is a lot of studies ongoing because Vibro's tactile for healthcare and rehabilitation has been used since a really long time, specifically in the haptics community. Specific to give stimulation maybe for motor control or something like that. And a haptic vest is basically a packaged version of a vibrotactile actuator. So probably yes. I think you can look for vibrotactile or vibration stimulation in healthcare and as a keyword in Google Scholar, and you probably will find it. But the haptic vest itself is just a packaged way for vibrotactile experiences that are used since quite a long time.
I've seen recently some research also around mental health and exposure therapy using vibrotactile vests, which is interesting because it creates the level of realism why the exposed immersion in the virtual environment gets more realistic and people react more heavenly to the exposure therapy than without haptic vests. So that's an interesting element.
Yeah, there are also a couple of things that they are used is that if you use a specific range of vibrotactile frequencies, they have a soothing effect on you. You can use it for meditation, you can use it for relaxation, or these type of things. So there's definitely opportunity to exploit this stimulation. And again, the question is always what's the goal and what you want to use it for. And a haptic vest is nothing else than a matrix of vibrotactile actuator. You can prototype by taking the phone and put it somewhere around you. Taking two phones or two people that put the phones around you and actually activate it. That is, you can prototype it really quickly before actually buying a vest.
Irina shared in the Riverside chat here the link to the article that I was referring to.
Thank you.
I believe as of now that is it on questions. So I will quickly share now the contact form. If anyone has any further questions later on, feel free to use the link that was just sent through both chats. And of course, you can find Eric's email on the presentation as well, which will be shared further. So if there are no other questions, we're also coming short on time, so it's a perfect timing. Then I would like... Sorry?
I see one more question from Nikki again. Sorry, looking into the chat. I'll read it out. Are the haptics made for gaming and are tested later in healthcare? So, are there are the haptics that come from gaming that are then tested in healthcare, or do you make haptics with the goals in mind, or with health goals in mind that are later used in gaming? So, are there interplay between haptics made for gaming and for healthcare?
So usually, and let's put it from a market perspective, usually gaming leads the way because it's a large market that customers are ready to buy an unproven technology. So what usually happens is that, like a Quest 3 is primarily a gaming device, right? And because they actually help to create the market. If for haptics you say devices, probably there are haptics devices built also for just for healthcare, like simulators, like surgery simulator or dentist simulator are haptic devices. So from a haptic device perspective, it might be absolutely possible that you can use a gaming device for healthcare. However, how you use it, as what I was stressing today, is where the magic lies. So a device is a, it's a piece of, it's a brick if you don't tell him what to do. And the magic lies on what to do, right? So definitely, I do see gaming devices like haptic vests, this type of things that can be used absolutely in healthcare. I don't see healthcare devices can be used in gaming because I really don't want to build a, let's say, dentist surgery simulator with $150,000 device and ship it to customers, right? So that's probably not. I mean, you can gamify that if you want to, but still, it's the purpose is quite difficult. And if you think about the effects, sorry.
Although everyone should feel the drilling into a teeth because it's
no,
you get goosebumps from it. It's
I freaking hate it. That's horrible. The worst demo ever. But however, the effects, which is what you make the device do, then probably doesn't really translate. That is the part of what you need to design there. Thanks for the question, Ben.
Yeah, apologies as well, Nikki, for reading over that last question. Now I believe that we have gone through all of them. So yeah, again, feel free if a question pops up later to use the link shared in the chat. And of course, Eric's email was shown before, which you will receive later as well, along with the recording. So I just want to thank Eric very much. We really appreciate you coming here. Super cool that you joined us. And also thank you to everyone who joined and watched this webinar. So that was all.
Cheers. Bye-bye.
Thank you so much.